The language of sets. Now, the key thing is about sets, and hopefully you've seen these before somewheres, is that they're a collection of objects, and those elements or those objects in that set are called elements. Now watch this. This is fantastic. See that? That's beautiful. Those are supposed to be set braces, and this is actually what they look like. So if you see that, that means that you have a set. And then the numbers inside, which is what we'll usually use our numbers, are called the elements. And so hopefully you've seen some of these, like the natural numbers. The natural numbers are known as the counting numbers, and they consist of the set of numbers that start with 1 and they count by ones. So 1, 2, 3, dot, 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 dot. Now this dot, dot, dot just means it keeps going forever. And then the whole numbers are the same as the natural numbers, except you start with the number 0. So 0, 1, 2, 3, dot, 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 dot. And then the integers are the same as the whole numbers, except it includes the negative natural numbers also. So it goes forever both directions. Now the rational numbers are nothing more than fractions. And fractions are decimals that end or repeat. So some examples of rational numbers are like 3/4, because 3/4 is the same as 0.75. I could say 0.5 is a rational number because it's the same as 1/2 as a fraction. And then you can say 2/3 because its decimal keeps on going. It repeats. It doesn't stop, but it does repeat. So either they stop or they repeat. In fact, the number 4 is a rational number because it can be written as 4/1 or 8/2, so on, so on, so on. So that just gives you an idea of what these words actually mean. Now, irrational numbers are numbers that aren't fractions. What that means is their decimals don't end and they don't repeat. And you have to have some kind of funny symbol to represent them. This handwriting is just terrific, isn't it? So let's some irrational numbers. Well, an obvious one that you may be aware of is the number pi. The reason why we have this symbol to represent it is because its decimal doesn't end and it doesn't repeat. Some other numbers have funny symbols. Square root of 2. The cube root of 7. So on and so on. I'm going to bring up a graphing calculator just so you can see. So on the graphing calculator, there's a pi symbol there. Well, if I bring it up, which that's not what I wanted. Hey, that was another irrational number, that e. If I just hit enter, it's decimal. There's no pattern there, and the calculator just goes to so many digits, but it doesn't stop. It keeps on going. The same thing, the square root of 2. Its decimal keeps on going also. It doesn't stop. And doesn't repeat. So those are just some examples of irrational numbers. Now, real numbers are pretty much any number in the number line, any number that exists, any number you might see in this class. It consists of all rational and irrational numbers. So list some real numbers: 0, -4, 2/3, negative square root of 2. You just keep on going. We're going to talk about some more notation. So let's look at this set A. Now this is set A. Set A is how you would say that. And it's represented by these three numbers, 1, 2, and 3. Notice the braces. Now if you see this element, this symbol right there, that funny looking E, what it means is an element of. So that's saying that 1 is an element of set A, and that's a true statement. This is saying not an element of. Because it's 5. Do you see 5 in that set? No, you do not. So since it's not, you just make that funny looking E with a line through it. Now the next example is kind of like what you might see in your actual homework assignments in the MyLabs Plus system. So we're going to replace this symbol with either this or with this. That's what we're going to use. So Is 3 in an element of that set? And the answer is yes. So that one would be an E symbol, the element symbol, if I can draw it properly. Now notice this. When you look at that, you'll notice the braces. As soon as you see those braces, that means that this is a set. So this set 5, is that in there? The answer actually is no, it is not. This set consists of just these 4 elements. This is a whole set. Is this whole set in there? The answer is not. These are just elements. So this would be, it is not an element of. It is a subset of it, but it is not an element. We'll talk about subsets in another video. For this to be a true statement, we would have to have written it like this. 5 is a subset of that set. So it is not. Bill Gates. Now, when you look at this, this is called set notation. Set notation, the way you read this is going to be read as X such that X is a billionaire. And in this case, that X represents the person or people. In this case, Bill Gates. So, is Bill Gates a billionaire? The answer is yes, he is. So we'll use that, and it's just a single person. There's no set notation around it, no set braces. So we'll use the element because Bill Gates is an element of the billionaire sets. If you don't think of it like that. And then the Ace of Hearts. Is it in this set? Well, this set, if you look at it, the most important part is this right here. Elf represents, or this set represents, off-base cards in a standard 52 card deck. I don't know what y'all know about cards, but there's 4 suits. And let me erase this a little bit. And we're going to use cards throughout this class. So if you're not familiar with them, let's become familiar with them now. We have hearts. We have diamonds. We have spades. We have clubs. There's 4 suits. These 2 suits are red in color, and these 2 suits are black in color. Now each suit has, we'll start with the smallest. Now the ace, depending on what game you're playing, could be the smallest, could be the largest. But they all have a 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, there's 13 cards total. And since there's 4 suits, 13 times 4 is 52. Now these 3 have faces on them. The Jack, Queen, King. An Ace does not. So does the Ace of Hearts, is it a face card? The answer is no, it is not. So therefore, it is not an element of it. The one you're probably going to have the most difficulty with is this one right here. If this is a set, it is not an element. So a set cannot be an element of another set. That's how you have to think about it. And so when on this set notation, the set builder notation, that's what I described up here. So this was your first experience in this class with set builder notation. That's what this is up here. So in set notation is where you actually list the individual elements. Set builder is when you use a property with a variable. So that's the difference. A lot of this is just notation, becoming familiar with it. Sometimes it's better seeing the actual example. And so let's see an example where we might have to, where we're given this is set notation. and you're asked to put it in set builder notation. So in set builder notation, what we're going to do is we're going to say it's some variable, let's just call it x, such that, and some books use a line, we'll just use the colon, such that if you look at these numbers, 3, 6, 9, 12, I mean, you can get really mathematical with this, but probably the easiest way to think of it is, looks like we're counting by threes, those are known as multiples. So you say multiples of 3, for example. We can get really technical, where x is a natural number. Watch this. That's what you call technical. Where x is that symbol means natural number, where x is a natural number. There's all kinds of ways you can write it, but if you see this multiples of 3, that's pretty good right there. I'll take that. Now in this one, in this example, this is set builder notation. We're going to write the answer in set notation. That just means we're going to list the elements in a set, in set braces. An even natural number between 11 and 21. An even you count by twos, a natural number between 11 and 21. So it means we can't use 11 because that's odd. So we use 12. Then even numbers are 14, 16, 18, 20, 22. Well, I can't go to 22 because that's past 21. So we're done. These are meant to be braces, by the way. I'm not the best at drawing them. But that's what set notation is. You just list them individually. Now there are some special sets, some other special notations and definitions. Empty set has no elements in it because it's empty. So if you see a 0 with a line through it, that's an empty set. So if you are accustomed to writing your 0 with a line through them, you want to stop doing that in this class because it actually means an empty set. Or if you see a couple of set braces with nothing in them. The empty set is a subset of all sets. That's going to be a big deal later on, so just be aware. We'll talk more about this later. Now, universal set, it's a set that contains all the elements of interest. This will be a big deal later on, so just remember it contains all the elements that we'll be looking at in a particular problem. So this is just a preview, or introduction to sets, is what it really is. Cardinal number is how many elements you have in a set, and the notation we use is and that's the name of the set. So this is asking the number of elements in set A. And I'm actually saying unique elements. So let's look at this example. This is set A. How many elements do you see? I count 1, 2, 3, 4. So the cardinal number is 4. It's not asking for the elements, it's asking for how many is in there, and there's 4 of them. That's what that means. N means number. N means number. Now for this one, what's the number of elements in the word mommy? X is a letter in the word mommy. So you might be inclined to say that there's 5, but there's not 5. There's not 5 unique. In fact, there's an M, and there's an O. I don't write the M down again because I already have the M. And there's a Y. So how many different ones do you see? 3. So that's how you think about it. Don't say there's 3 M's. There's only an M that's used 3 times. That's how you think of it. And then the O and then the Y. So there's 3 of them. 1, 2, 3. And welcome to the introduction of sets.